Good evening and welcome to the London School of Economics. My name is Sam Fankhauser. I'm director of the Grantham Research Institute on Climate Change and the Environment here at LSE. Grantham is sort of the kind of locus where research on climate and the environment happens at the London School of Economics. Not exclusively, but we're sort of the predominant place of environmental and climate change research at the LSE. It's therefore a great pleasure tonight to host this lecture. It's a great time also to host a lecture on the environment and on climate change, partly because it's the first week of term and students are meant to be fresh after their break. Partly also because we're in a very exciting time when it comes to the environmental and in particular the climate change debate. I've read a statistic over the weekend. Apparently climate change has had the highest mention in the press, certainly since the Paris Agreement at the end of 2015, possibly the highest mention in the UK press ever. Of course we know why this is. We have just had a week of demonstrations by Extinction Rebellion. I've seen the logo on a couple of your sleeves, so I know you're here. We've had a visit from Greta Thunberg, the Swedish climate change striker and activist. We've had a couple of really great programs by David Attenborough. If you haven't seen them, go away and find them and look at them. They're really, really very powerful. On the sort of more nerdy end of the spectrum, one of my colleagues reminded me on the way over, we've had a really great intervention from Mark Carney, the head of the Bank of England, the UK Central Bank, on climate change. And on Thursday this week, we, in a sense, I hope, we will get the reaction of that sort of popular emotions about climate change when the Committee on Climate Change will give its verdict on whether the UK should adopt a net zero target. So that, in a sense, will be the policy and the political reaction to all the visibility and all the campaigning that we have seen. And the question after that, of course, will then be fine. Hopefully we will say fine. We now have an ambitious net zero target. The question will then be on how on earth are we going to achieve that? And one of the people who is best placed to answer that question is our speaker tonight, Mike Berners-Lee. So it's my pleasure to welcome Mike to the London School of Economics. You probably all know him. Might not be here if you didn't. But Mike is a professor at Lancaster University. He's also the founder of his own consulting company called Small World Consulting. And he's one of the world's experts, sort of on a technical level, on environmental footprinting, on sort of finding out what is the carbon, water, energy footprint of various activities and various commodities, from cars to bananas, sort of looking at his CV. More broadly, and I like the job description, if you look at how Mike himself describes his function. He said he is a big picture, multidisciplinary thinker about the challenges of the 21st century. Brilliant type of job to have, a brilliant type of activity to engage in. And so with that sort of pedigree, obviously Mike is the person to tell us how on earth one does things like net zero. He's also today talking about a book that's just come out about a month ago. There is no Planet B, a handbook for the make or break years. I hope you have taken the advantage to buy a copy on the way in. If you haven't, you probably want to buy a copy on the way out, because after that you will have had a great introduction from Mike on No Planet B. Mike, the floor is yours.
Well, thank you, and thank you for that introduction. Thank you for coming. Background to this is, so I wrote a book about carbon footprints a while ago, and that was okay as far as it went. We need to understand about carbon footprints if we're going to get on top of climate change, but clearly that's not enough. So I co-wrote with Duncan Clark a book about the big picture of climate change, and that was okay as far as it went. But actually, if you really want to deal with climate change, you need to see climate change as a symptom of something much bigger that's going on. And so that's what this book is about. That's what this book is, my humble attempt to get on top of. That's the off button. There we go. So just to try and sort of frame up what that bigger thing is that's going on. So this is just a simple, slightly stylized graph of human energy supply and use since 1850, but you can trace it back to year dot. And every year humans have been having more energy in their supply at their disposal. And for the last 50 years, it's been going up at 2.4% per year on average. And we use that energy for all kinds of different things. We use it to travel around and to keep warm, and every year we get more efficient with how we use that energy supply, and we get more innovative. We invent new things to do with it as well. And with all that energy, we get to be more powerful. We get to do all kinds of different things. And that's okay, but we influence the planet that we're living on through a mixture of accident and design. And that's fine when we're, as things used to be, a small species running around on a big, robust planet. And until recently, we could get away with thinking that the world was a big, robust playground for us. But as we've been getting more and more powerful, the planet's resilience against everything we can throw at it hasn't been getting greater. And that was fine for a long time, but then suddenly the balance changed, and it's really, really recent. So if you go back 100 years ago, even 100 years ago, we couldn't smash the whole world up even if we tried, and we did try pretty hard, but we couldn't smash it all up. And sometime around 50 years ago, somewhere around there, we got to the point where we realized, oh my goodness, we could really make the whole planet inhospitable for humans and other species as well, probably. And that was pretty shocking. But our energy supply is going up at 2.4% a year, which is a factor of 10 every century. And not only that, but our power is going up even faster because we're getting more efficient and we're getting more inventive. So in the last 50 years, we've invented new chemicals and new processes and all kinds of things we can do with it. And so our power over this planet has got vastly more again. So my sort of simple picture to show you to describe the big thing that's going on is that, see if my pointer works. It does, yeah. So we used to be like this. We used to be little people running around on a big, robust playground of a planet, and then suddenly it's like this. And some people use a big word for it, call it the Anthropocene. It just means that suddenly the big thing that's influencing the ecosystem is us. And that's a completely different context for humans to be operating in. And it's really, really recent. We can argue about exactly when, but the time in which we can't any longer get away with treating the planet as if it's robust, has only just happened to us. And yet all the ways in which we do life, the way we do our economics, the way we do our politics, the way we've learned to solve problems, the way we've learned to think, the way we do society, that was all honed in this context here. And suddenly we're in a situation where some of it may not be fit for purpose still. And if it's not, we better change it urgently, because we're suddenly powerful enough that we won't just trash the planet by doing something really stupid. We will trash the planet really quickly, and we are doing, if we're not really, really careful to look after it. So the quality of our stewardship suddenly has to be unlike anything we've ever known before. So that's the big thing that's going on. And so I wrote this book about it, and there it is. And that's a draft of it. You can see the bits in yellow. So here we are in a situation where we're faced with all these global systemic challenges, all interlinking with each other. And It's no good looking at one of them at a time. We have to, like it or not, we have to look at the whole thing at once. All the science and technology, but all the other disciplines as well. We have to try and see the whole picture at once. So really, it's not a book that ideally you wouldn't read it, page 1, then page 2. You'd actually just try and absorb the whole thing at once. So what I'm going to do is I'm going to keep quiet for about half an hour now and just ask you just to stare at all that and just try and absorb the whole thing, because we need to hold it in our heads simultaneously. So here it is, it's a short book. It's full of kind of analysis and numerical analysis and statistics and graphs and stuff. And the reason I've put them in there is because they are perspective forcing. I've put things in when I think that there are bits of perspective that make you go, oh my goodness, how come we're doing that to the planet? Or how come we're living like that when we could be living like this, when we've got the opportunity to live like that? And how much trouble we're going to be in if we carry on as we are, but equally, how brilliant things could be if only we could just live a little bit differently. Just before I go any further, I just want to nail this question of, is there really no planet B? Since it's the title of the book, and also it's because we've all been brought up with science fiction on the telly, and I was brought up with Star Trek, and there was an age when I kind of really did imagine that the future was running around between different planets and stuff. And Elon Musk talks about it as if it's a real thing that's going to happen, and even the late Stephen Hawking said things on the lines of, we're not going to be leaving the planet for the next 100 years at least, so we better be really careful in the meantime. Well, that sort of implies possibly that maybe shortly after 100 years we might be leaving the planet. So let's just have a look, and this is just really, really simple physics. So the nearest planet that could be any good to live on is 4 light years away. I'm talking about somewhere where you can get out of the spaceship and walk around and maybe have an atmosphere and stuff. So it's pretty local, 4 light years away. And if you're prepared to have a long journey, 40-year journey, then that's okay. You only need to travel at 1/10 of the speed of light. So let's just have a look at the kinetic energy that a person traveling at 1/10 of the speed of light has. And it turns out to be the same amount of energy that 500,000 average global people get through in a year. 500,000 people's annual energy use in a year. And that's just a person flying through space in their underwear, no spaceship, nothing like that. So let's just begin to think about some other things. So I did some calculations. I put people in a spaceship that was the size of my little C1 car. It's a small car which I can assure you I don't want to spend 40 years in. And looked at what about you might want some kit for the journey, and maybe some kit for when you land on the other side, and maybe even something to help you slow down so that you don't charge into your new home at 30,000 kilometers a second. And by the time you do all that, let's not get too obsessed with the fine details of the numbers, but just to suffice to say, a small handful of us on a journey like that would take up the whole of humankind's annual energy supply. So it isn't going to be happening. Humanity is not going to be escaping off to another planet. We are on planet A. Luckily, planet A is a good one to be on still at the moment. Still nice. So so just to make the point, so Star Trek was definitely fiction, and we need to nail that idea. And I think it's actually a serious point to nail it, because I think that idea is in danger of having some traction in the back of some people's minds, that maybe this one planet living thing is only temporary in some way. It isn't. Okay, so just a little collage of some of the things I talked about, how it was this joined up challenge of lots of different things we need to think about at once. So let's just have a look at some of them. So this is just to try and present a picture of some of that. So we hear about some biodiversity stuff, so there are some insects that we need to worry about, and some of the news on insect populations, should be giving us a little flutter of fear when we read about them. And obviously there's plant species as well. And one of the species is us. It's that species there. Look, and there's more and more of us every year. And we live on this lovely planet, but we're filling it up full of plastic. And we all have to eat somehow. So there's some food. And the food has to come from somewhere. Some of it comes from a chicken farm like that, and some of it from cows like that. Some of it from sheep near where I live in the Lake District. And that's just a picture of some antibiotics, representing some antibiotics. So there's this kind of looming antibiotics crisis coming up, and at least 2/3 of the world's antibiotics are fed to our farm animals, and just contemplating a world in which our antibiotics aren't working properly is pretty is a pretty scary thought as well. And we have, of course, our energy supply, and some of our energy comes from things like that, and some of it comes from things like that, a little bit comes from things like that, and just a trace of it comes from wind farms. And there's a symptom of all the climate change stuff that we're having to deal with. And then, of course, we all have to live somewhere. And some people live in places like this, which is London, and some people live in places like this. And one of the questions that we might want to think about is, is it actually possible to deal with some of these questions like climate change, which maybe we need some global cooperation over? Is that actually possible, that kind of cooperation, when there's this level of inequality going on in the world? So that's just a kind of sketch of some of the things, some of the kind of physical challenges that we've got. So there we go, there it is in words. So we've got to, at the same time, we've got to deal with energy, climate change, or maybe climate breakdown is a better expression for it, and obviously they're interlinked. And at the same time as that, we've got to feed everybody, a growing population. And there's ocean acidification that barely gets talked about compared to climate change, but it's probably just as scary. Luckily, the solutions are pretty similar to the solutions to climate change. I've mentioned antibiotics already. Meanwhile, we've got this biodiversity crisis going on, absolutely hemorrhaging our biodiversity. We need to deal with that at the same time. And we've got plastics that we hear about, a lot about. And there's other pollutants as well. And while we deal with all those, we've got to deal with how we do our transport somehow. And just by the way, we've got this question of this rising population, which is clearly part of the critical sort of part of the equation. So those are just some of the physical things that we've got to deal with. And the good news, just to cut to the quick, the good news from the science and technical perspective is that, broadly speaking, all these things turn out to be solvable. Isn't that great? The technologies that we need are there or thereabouts, more or less. So what would it take for us actually to be solving them? And that takes us into a whole load of other stuff, which is essential to look at at the same while we're at it. So that takes us into questions about, for example, growth. So some people are saying growth is the root of all evil, and some people are saying it's essential. And I've got a slightly different sort of take on the growth question. And then what about the role of technology, which I'll talk about just a little bit. So we've been in this dynamic in which our energy supply has been going up. We've been using that energy with ever increasing efficiency, and that increasing efficiency has, at the same time we've been developing a whole load of new technologies, and that technology has been fantastic. And just by the way, I would be dead several times over probably without at least some of those technologies. So it's been great that we've got all this technology, but at the same time, they are enabling us to increase our impact on the planet. And it's quite clear, it's really, really clear that is getting we are not at all far away from getting ourselves into a lot of trouble over that. So there's something about how are we going to do this technology now? Who's in control of it? Are we in control of it, or does it control us in some way? Are we kind of trapped on some kind of dynamic where we have to have every new technology, where we develop every new technology that we're capable of developing, and then if it gives us an efficiency improvement, we're unable to resist it, so we take it anyway, and whatever its impacts on human well-being or the well-being of other species? Or is it possible to be more discerning about all that stuff? So that's technology, and then there's stuff about business and politics and economics. It's unsurprising that I said that a whole lot of stuff that was honed in the millennia while we were still a small species running around on a robust planet may not still be fit for purpose in the completely new context that we're in now, and economics comes into, some of the economics kind of comes under that kind of scrutiny. And, and linked to that are metrics, and I've mentioned about inequality, and our politics, and then questions about truth and trust and values, which I'll touch on, and then there's a bit in the middle, and this is the kind of conclusion of the book, is it's all about some stuff about thinking skills and habits. Maybe there are some ways of thinking that we used not to have to be very good at, and now suddenly we're in a world in which we need to really quickly get better at some new ways of thinking. So that's a kind of quick tour of the terrain. I'll get into some of the detail, and it is a book that's packed full of stuff, so I'm going to just be picking at bits of it. So to look at some of the stuff in green first around the edges, some of the physical challenges that we've got. So first up, to look at some of the stuff about land, food and sea. So just to look at, this is some research we did at Lancaster, just looking at all the human nutrients on their journey from when they're grown as crops through to our mouths and other endpoints. So just to look at that. So some of the writing's a bit small, but don't worry, I'll talk you through it. So the green chunk here this is just representing in calories per person per day at the global level. How many calories do we grow in crops? And it turns out to be just short of 6,000 calories per person per day. Something like 2.5 times what humans need to eat. Isn't that fantastic? How could anyone ever go hungry? And at the same time, in brown here, I've got this grass, pasture and stover, nearly 4,000 calories in grass, pasture and stover that we can't eat, but animals can, and we feed it to farm animals, and they have that energy as well. So what happens to this fantastic surplus? And by the way, for speed, I took this slide out, but you can look at this at a regional level, and what you find is that every region of the world has also got a really good, healthy surplus, and some more than others. So in America, it's something like 20,000 calories per person per day, just absolutely tons. And in Africa, it's a bit thinner, but it's still close to a double up on what's needed. This is just the calories, but I'll just say we did this for all the essential human nutrients, protein, vitamin A, iron, zinc. It got a very similar story from them all. So there we go. What happens next? Well, a little bit gets lost in harvest losses there, and that's something which we can do something about. It's very hard to get it to zero. You know, it's about inefficiencies in the harvesting process. Sometimes it's about a supermarket deciding that it's got a glut and it just doesn't want that food to come out of the ground. But usually not. Usually it's just an inefficiency. But it still leaves us plenty, so what happens next? Okay, so we lose some in post-harvest. So that's in storage, and that's mainly a developing world problem, and it's mainly about just not having a decent place to store food so that it doesn't go off. So that's that bit really looks like we can do a lot with, but it's still a relatively small part of the process. So there's still plenty left, 5,265 calories there, fantastic. What happens next? So this is an interesting bit. We divvy up what to do with it. So the little yellow sliver here is a good idea. This is the bit that we have we save as seeds for next year so that we can eat next year as well. That's a good thing to do. And the green bit here is also a really good idea because we have that stays in the human food system. That's crops for eating. And then the blue bit here, about 800 calories per person per day, is non-food uses. So that's almost entirely biofuel, which is not necessarily bad. We know we've got to have a non-fossil fuel energy supply. But just to give you an idea of the trade-off, if you have enough wheat to feed me for a day, give me all the calories I need for a day, but instead of doing that, you use it to create biofuel to power my little C1 car. It's a little 1 litre, I can get 70 miles to the gallon out of it if I'm careful. To power that car instead, you could create enough biofuel to power that car for 1 mile. Right? So that's 1 mile against a day's calorific intake. It's a really steep trade-off. And if we can crack properly how to do second-generation biofuels using a cellulose crop to create biofuels, we might get it up to something like 5 miles, but it's still an incredibly steep trade-off. And then the brown chunk here, about 1,750 or so calories per person per day, is human edible crop that we feed to farm animals. So the farm animals eat this, and they eat this. So let's see what happens next. So then we've got, so the farm animals eat this, and they give us back this red bit here, nearly 600 calories per person per day. It's not nothing. And all this bit gets lost through animals doing inefficient stuff like walking around and keeping warm and things like that. So there's a huge kind of efficiency loss when you put animals in the system. And this land here that's used for grass and pasture, some of it couldn't be used for crops, but some of it could. And some of it could be fantastically set aside for biodiversity as well. So, and this is nearly 3/4 of the human calorific requirement. So if we were to stop feeding human edible crops to animals, then the the spare capacity that we'd put into the food system would just be brilliant. We could use it to feed a growing population, and we've looked at this, we've modelled it. You could feed the 2050 population without changing our agricultural output at all. Or you could use it for biodiversity and possibly a bit more biofuel, although that trade-off is so steep. So let's see what happens next. I'm not a vegetarian or a vegan, by the way. It's all about proportions, right? It's not that we can't have any meat and dairy, it's about proportions. And then we lose a bit in distribution and processing, and we lose a bit more in consumer waste. Not much in Africa, but consumer waste is a big deal in countries like this. But it's okay, because we still have 2,530 calories per person per day actually going into our mouths, which is more than we need. So there's a net excess consumption. Some people don't get enough, but on balance, we eat more than we need. And there's a little the book's laid out in questions, 100 and something questions. And one of the questions is, why don't humans explode if they eat too much? And actually, a really small calorific intake over what you use in a day would quite quickly lead to us all getting to the point where we physically couldn't walk, and we would actually just be dead in not very many years. But luckily, we get less efficient as we get bigger, so that's why we don't explode. So there it is. So what does this tell us? What's the point of this? This tells us a few things. First of all, of course, we should try and minimize our losses, all the bits in grey. But that's not the biggest story in this. The biggest stories are, one, the inefficiency of feeding human edible crops to animals, and linked to that, the amount of meat and dairy in our diet. There's no getting around it. Even the BBC understands this now. It's fantastic. That needs to change. It doesn't. If you're scared stiff of the idea of a meal without meat in it, it doesn't need absolutely to change today, but over the next few years, the amount of meat and dairy in the global diet, and especially in the UK diet, because ours is out of kilter even more than the global average, needs to come down a lot. And that's, it's clear cut. Not just from the point of view of feeding everybody, but also from a greenhouse gas perspective, which I think I've got slides on in a second. And then the third thing is just to watch this biofuel thing like crazy, because just imagine that we achieve the global arrangement to leave the fossil fuel in the ground, and yet we keep hold of a free market in which farmers can do whatever they like with their crops. Then the commercial incentive to go and expand that blue bubble into the green bubble, the green block, at the expense of our food supply would just be enormous. For hardly any fuel, really. Just to give another example on that, if we wanted to replace all our aviation fuel with biofuel so we could do low carbon flying, that would come at a cost of something like 2,100 calories per person per day for everyone in the world to replace the world's aviation. So it's colossal cost to the food system. Okay, and just to emphasize the point about the inefficiency of animals. So here we are, soybeans against beef, just gram for gram, 100 grams of each. So there's the calories. So there's more calories in this. I couldn't believe this when I first saw this. More calories in the soybeans, more protein in the soybeans, more iron in the soybeans, more zinc in the soybeans, and more of just about every essential nutrient you can get. And yet, when you feed 100 grams of soybeans to a cow, you get something like 10 grams of beef back again. So it's just colossal inefficiency. That graph I showed you here, so we did this, you can do exactly similar graph, and we've done them for protein, zinc, all the other most critical nutrients. Okay, and then I've mentioned antibiotics already, and I've mentioned the inefficiency of animals. Just one way that you can improve the efficiency of animals a bit is to keep them in a small space so they don't do so much walking around, and pack them full of antibiotics so that they grow faster and so that they don't get ill, and then kill them quickly. And so if you just treat, such as is going on here, for example, so if you just treat an animal as a food factory for humans, that's the way that you can put the efficiency of it up higher. I'm not advocating that. Okay, just quickly on fish, just one question on fish, which I'll just do. So when's a sea bass not a sea bass? Because fish deserves a mention since we're talking about the food system. And the answer is when Well, it's a Patagonian toothfish, and it's just been renamed for marketing purposes. And it lives down in the this really is true, and it lives down in the Antarctic Ocean, the deep sea, up to 3.5 kilometers down, and it takes 45 years to grow. So if you pull one out of the ground, out of the sea, it takes 45 years before you can have a new one. Fantastic nutrition source down there whilst it lasts, and 80% of it's coming from unregulated fishing, by which we're talking typically about slave ships out there, never coming into port, totally unregulated, completely off the radar. They refuel out at sea, they unload their cargo out at sea, and they're just completely off any legal system. If we were to do our fishing sustainably, really, really carefully in a much more regulated way, then we could potentially, we could get away with the global average, which is about 30 grams per person per day. So there is a role for fish, but we need to treat it like a treat, just like the meat and dairy. Okay, so just quickly, some food practicalities. What does it take us to? There's no getting away from this. So less meat and dairy, especially less red meat. They're the ruminant animals. I haven't put the slide up about the carbon footprint of different foods, but just to say that when the cow gives you its beef back in return, it's that 10% of the nutrition that you put into it. It also gives you back with a big helping of methane, which is a big, powerful greenhouse gas, and sheep do the same. That makes beef and lamb the highest carbon or the highest greenhouse gas meats. But every kind of meat is inefficient. These are in a kind of hierarchy. Less dairy, although dairy is a little bit more efficient than meat, generally speaking. It's more efficient to keep the animal alive. Self-explanatory, but eat what we buy. Treat fish as a treat. And then lastly down here, get to know our supply chains. This doesn't just apply to food, but we're living in this world where we just see things on the shelf, and we just buy them, and we need to get to a point where we are thinking, well, what lies behind this food? Did it go on an aeroplane, for example? Because if food goes on a boat from anywhere you like in the world, that's fine. The minute it goes on an aeroplane, it's a carbon disaster. And so we need to tune into our supply chains. And then just, what needs to happen at the global level. And the book is kind of riddled. The idea of the book is to sort of have all these kind of what can I do questions answered, as well as what should be happening on the bigger scale question. So, we need a shift from global meat, away from meat. We need to reduce inequality, something I haven't mentioned. In that map where the calories go, there was a surplus. There is no net shortage of food. And that's a really important thing to notice, because the reason why some people don't get enough or don't get the right nutrients is not that there's a shortage of those nutrients. It's that the supply chain doesn't find its way to their door. And the way the market works at the moment, the reason for that is that it takes money for a supply chain to bother to find its way there. And you can increase the food supply as much as you like, but until there's actually some way in which people can afford for the supply chain to find its way to their door, then that food doesn't become available to them. And so, doubling the food supply wouldn't stop some people going malnourished. So there's an inequality angle to this. Keep biofuels in check, I've mentioned. Roll out efficient crop practices. There's actually a lot we can do with just existing practices. More farmers, not less. It's really interesting. A lot of our agricultural system is geared towards the maximum efficiency in terms of, the fewest people working the land, the better, because that's more profitable. But actually, it takes care to do the right thing with the land, and we've got more people than we've ever had before, and we're going to have even more of them. So the most sensible thing to do is have more people working the land somehow. And on seas, just better, more protected seas and regulated fishing. Okay, so that's a whistle-stop tour of some of the stuff in the food and land stuff. On to energy and climate change, which I'm going to just talk a little bit about. There are, at one point in the book, there's 14 things that everybody needs to know about climate change. I'm going to cover some of them off here. And it just says, and at the back there's an appendix that fleshes that out into about 10 pages or so. And with a request, please don't, if you have a choice, please don't vote for a politician that doesn't get and take seriously all 14 of these points. So there's a little checklist for you. So here's the first thing. So here's just a graph of carbon emissions going up, there it is, up to 2018. And the biggest thing to notice about that curve is that it's going up exactly as we might have predicted it would have gone up if humans had never noticed that climate change was an issue. Exactly the same way. There is not one hint of a detectable trace of evidence that that curve has noticed anything we've done about it, climate, the Paris Agreement, or anything. And I'm not saying this to be depressing about it. I'm saying it because it's really important evidence to stare in the face. It tells us an awful lot about what won't solve the problem, and if we're clever, it can tell us a lot about what might solve the problem. So one of the things that's going on is there's a kind of a balloon squeezing effect. We make little savings in one place. We have a country that's got emissions targets like ours, and it's succeeding maybe in meeting them. And we have individuals who do things to cut their carbon, and we have companies who try and do the right thing. But somehow it doesn't add up to some change. It adds up to nothing. And that's because somehow at the global system level, it's working like a balloon. You shrink it in one place, and the emissions migrate elsewhere. They pop up elsewhere in the world through a whole load of systemic effects. So there's a big system dynamic going on, and we have to change it. Somehow we have to interrupt the global system dynamic in such a way that creates this change. And then this is actually from my last book. I just lazily put a slide from it in this. This is how much fossil fuel there is, the reserves that we know how to get out of the ground, and this is how much this is how much we can burn to have a 75% chance of staying within 2 degrees, which the IPCC is now saying very clearly, the scientific community is saying very clearly, is really, really risky. In fact, they're saying that 1.5 degrees is probably a bit more risky than we used to think 2 degrees was. And then here's the most interesting thing about the climate change challenge is this, the human response to it. And that's really the nub of it, isn't it? So, if we could just understand that bit. So what would it take for us to wake up and have this system change? And as Sam mentioned just now, we're in a really interesting moment. So when I wrote my last book, my co-author and I were kind of scratching our heads going, God, how this stuff is so clear cut. The broad science is so staring us in the face. How come no one's doing anything about it? It doesn't feel quite like that at the moment. It feels more, I'd say it feels, in some ways, the science has got quite a bit more scary than when that book came out. But on the other hand, the human response looks more hopeful. We can debate this, but possibly than it's ever looked. More on that later. Just quickly, the human energy supply. So we get to 59 kilowatt hours per person per day, global average. And here, these ones are all the fossil fuel. And that little green sliver there is the renewable energy bit. The other renewables, apart from hydro, and we've got the wood here up in red here. And this bit here, which is kind of reassuring, this is the bit that we've had since year dot, the most traditional form of human energy, the 5% that actually comes into our mouths. It's still there at 5%. And the good news about that thin green sliver is that if you look at solar panels, the potential for the solar revolution, that dot is to scale. If we had solar panels the size of that dot, that would be enough to replace the whole of the human energy supply. Now, there's a lot of devil in the detail. We need to transport it, and what do we do about storage, and what do we do about days when the sun's not shining, and all that stuff. But all this is covered in the book too. It turns out these things are, broadly speaking, they are solvable. Isn't that fantastic? Great, so we'll just solve that then. And we really could, you know, there is no inherent reason why we can't do that. There's no limiting factor on solar power that stops us doing it. But I said that human energy supply was going up at 2.4% a year for the last 50 years. And if we carry on that trajectory, that's a factor of 10 every century. So let's have a look. So in a century's time, it's going to look like that. And in 2 centuries' time, it'll look like that. And in 3 centuries' time, it'll look like that, with no opportunity for a human on land to have any sunlight falling on their skin, because that would just be too inefficient. So I just make this point to say, you know, if we're going to transition our energy supply, that's fine. But what about our growth in energy supply? At what point are we going to get to a point where we actually can do without more energy? And some people say, well, we're naturally going to become satiated. But I think you've only got to look at things like Bitcoin or space travel, space tourism, or any number of new technologies, or even the possibility of taking water, desalinating water and pumping it into the desert to make the deserts arable and so on. The scope for humans to want to increase our energy supply is just enormous. So somehow we're going to have to get to a point where we live within a constraint. It's no good having the renewables as well as the fossil fuel. We need to have them instead of the fossil fuel. And that means, surely, that means tapering off the growth in our energy supply. Just have a look at who gets this sunlight. So this map is to scale in terms of the sunlight, and the colour scheme is the sunlight per person. So there's Australia, looking dark because it's got so much sunlight per person, actually 200 times more sunlight per person than we've got. We're the 5th worst country in the world. Just ahead, seriously, just ahead of Bangladesh, the Netherlands, Belgium and Rwanda. And that's it. The Australians got 200 times more sunlight per person than we've got. And somehow, if we're going to leave this fossil fuel in the ground, one of the things that needs to happen is that we're going to need to come to, and this is talked through in the book, the rationale for this, but we're going to need to come to a global agreement to leave the fossil fuel in the ground. Somehow it's got to become too expensive, illegal, or whatever. I mean, I think it boils down to some kind of carbon price somehow, whether it's a cap or a price or whatever. It's going to have to happen. And you know, I struggle to find anyone who can find a different explanation for how it would happen. So if that's going to happen, how are we going to come to an arrangement that everyone can live with? Well, let's see who's got the fossil fuel and who's got the energy. So who's got the sunlight. So here's the fossil fuel reserves, the countries with the biggest fossil fuel reserves, and luckily, and I thought this was a coincidence when I first saw it. Of course, it's not a coincidence at all, but it lines up quite nicely with the countries that have the most sunlight. That's why they grew more trees back in the past millennia. So more or less, the transition is possible most of the time. But there still leaves the question of sharing it out. If we're going to make this transition, how can we do it in such a way that everybody can live with? So there's not enough politics in my book, probably. It's just my humble attempt to cover everything off. I'm sure there's not enough on politics, but somehow, just to say some kind of global arrangement is going to have to be done, and surely that's going to need some huge change in the way global politics happens. Because we were looking so sort of skinny and pale in the last picture I showed you, I just thought I'd show you the UK in terms of wind, which is nothing like such a good resource as sun power. But there we go, there we are, looking a little bit better, just a little bit darker and a little bit less skinny, so it's kind of just to be reassured slightly. But the renewable energy equation for the UK is a lot more challenging than it is for some countries. It's going to be a very interesting mixture of different bits and bobs. Just quickly, I'm just dotting through bits and pieces from the book, but just a couple of things on travel and transport. So there's all human travel in travel miles, 27 trillion travel miles a year or so, estimates. This is the walking in green, and that includes everything. So if you go between the kettle and the sink or something like that, that's included in this. And there's the car miles, growing, and then we surely got to do something about that. And then here's the rail, more or less static, possibly growing a bit. And then the other one we really need to watch is the air miles. And there's a bit on flying in the book, but just to say now that one of the crunches of the low carbon world is we actually don't know how to put aeroplanes in the air for long distance travel without burning liquid hydrocarbons. And we're miles away from a solution to that. Short haul travel, we can possibly not that far away from electric planes, but long haul, we don't know how to do it at all. So, just one more thing on travel. So, come the low carbon world, just about all travel is going to require land, one way or another. You could either use it to grow a crop, to create a fuel to put into a car, or you could grow a crop to put into a person so they could have energy so they could get on a bike, or you could put a solar panel on that land and use it to power a car, or you could put a solar panel on the land and use it to power an electric bike. So let's have a look. If you have a square meter of land in sunny California, this is based on, per year, how many miles of transport could you get out of each year? So just a little graphic. So this is for this is second generation biofuel for a little efficient car. So this is a cellulose crop. We don't quite know how to do this properly yet. But going into a car, and that's my little illustration there, a piece of string to represent 5 miles per year you could have from your square metre of land. What about if you grew wheat instead and turned it to bread and fed it to a cyclist? So there you go, 25 miles, much better. And there's the piece of string. What about if you put a solar panel on it and you power a car? 1,000 miles, just over 1,000 miles. What about if you put it into an electric bike? Whoa, there you go, 21,000 miles. I was a bit sad by this, really. I would have far rather the traditional bike won out, but I'll still be doing the traditional bike just because it's better in so many other ways. But yeah, so the electric bike is going to be a massive way of getting around, but also just to illustrate the efficiency of a solar panel compared to a plant at getting hold of the sun's energy. Okay, so I'm not going to go into a lot of the other things I touched on in the book, the other pollutants, plastics, ocean acidification, and so on, and population growth. But just to say that the one thing I'd say about population is that 12 billion really careful people could live well on this lovely planet of ours. 1 billion careless people will trash the place in no time at all. So it's not that population isn't an important issue. It is a really important issue. The fewer of us there are, the easier it is for us to give everyone the nutrition they need and the lifestyle that we want them to have and so on. But it's not the kind of single issue thing that some people talk about it as if it is. Okay, so what would it take for us to be, I've said that the one-liner is that all these problems turn out to be solvable. So what would it take for us to be solving these things? Okay, so on to some of these other things that I've just touched on. Growth, technology, business, politics, values, trust. I'll just touch on some of these now. I don't want to talk for too much longer. But so some people say growth is the root of all evil, and some people say it's absolutely essential. I would frame it up differently and just say what kinds of growth are still good. So I made this graphic up in the shape of an exponential curve just to be reassuring to anyone who just kind of likes exponential curves. But it's really just, to illustrate the point. So greenhouse gas emissions, it's clear we can't keep growing our greenhouse gas emissions. That's very, very bad. It's clear we can't keep growing our meat consumption. That's very, very bad. The science is clear cut. GDP, well, that's interesting. I mean, it's going hand in hand so far with increased environmental burdens, but it's just an abstract human construct. I could imagine a world, in theory at least, where GDP went up and our environmental impact went down. It's possible. It's a theoretical possibility at least, even though it looks dangerous. Population, we can have a little bit, but it's tricky at best. But then there's up at the other end here, maybe there are some things that it's really possibly essential to keep growing. So things like our capacity for global empathy now that we're all living on this planet together. What about our capacity for mindfulness so we can actually notice what's happening? Or our compassion or our ability to do systems thinking so we can do all this big picture thinking about everything at once. Maybe those are things we can still aspire to grow, and human well-being maybe as well. It's not that we can't do growth, it's just we need to completely change the flavour of our growth and the metrics that go with it, and a complete reorientating of ourselves. So I touched on inequality and this question of inequality because so if we're going to need to have some global cooperation over these things and consider ourselves as one global tribe, surely we're going to need to get to a situation where there's a sense of kind of fair play over these negotiations, so that we can look each other in the eye and trust each other a little bit. So let's have a look at just some illustrations of the state of inequality at the moment. So in America, it's particularly extreme. So why are most Americans poorer than most Italians? When Italy, you can see this is wealth per person. There's the States, there's Italy. And the question in the book should have been most Spaniards. Here's Spain there, much less rich than the United States. So that's the mean wealth. Let's have a look at the median wealth. So that's the wealth of the person in the country who's got as many people richer than them as poorer than them. And it's a better it's a better measure of how wealthy are most people. So there we are, it's coming up in yellow, and suddenly the States is right down there. And so most people in the States poorer than most people in Spain, quite a bit poorer than most people in the UK, actually poorer than just about everybody in the developed world. So it's kind of, isn't that amazing? So why would that be? Well, just so much wealth in so few hands. Where it's completely wasted, there's plenty of evidence to say that beyond a certain level of wealth, it actually does nothing for your well-being at all. So just to illustrate that slightly further, so if you took the 10 wealthiest people in the United States and just trimmed them down to billionaires, so you're not inflicting any suffering here, just trim them down to just billionaires, and shared it around the poorest half of Africa, you could quadruple the wealth of the poorest half of Africa. So, and as proof of the idea that the correlation between well-being and wealth breaks down, these people would all just be wandering around in a dreamland, wouldn't they, of just delirious happiness the whole time, wouldn't they, if it correlated with wealth? Clearly it doesn't. And then I'll skip over this, but there's a bit in the book about just disproving the trickle-down. I'm going to skip over this, but it's just a quick disproof of trickle-down. I'll just talk you through it. Don't bother with the slide too much. But so what happens? So is poverty about relative poverty, or is it about absolute poverty? And from the food slides, you could see that what happens if you've got somebody who knows that if they can't have a certain kind of food, they're going to die young, and they're trying to buy it because they're putting all their effort into buying that food. And there's somebody else on the other side of the world who's 1,000 times richer. And they think that, it would be nice to be able to have a bit of biofuel for their private jet. If the free market is allowed to do its thing, the land will be used for the biofuel for the jet rather than the food supply for the person who is 1,000 times poorer. So, it's a relative thing, it's an absolute thing, and it's a relative thing, not an absolute thing, that is important. So this is just a disproof of trickle-down, a disproof of the idea that if you make the rich richer, it's good for everybody because the poor benefit. It's the ratios that matter. Just quickly on to truth and trust. I won't talk through everything in the book. There's a whole chapter on this in the book. But, we're in this world where everything's so complex, and it's more complex than it's ever been, and everything's so joined up, and it needs all this. The technology is more complicated than it's ever been before. And that leads to two things. One is we need the cleanest view of what's going on that we can possibly get, much more so than ever before. But it also means it's easier to disguise that. It's easier to just fudge that around. So we need to get much, much more astute at looking at those faces that we've got there and having a really well-founded basis for saying which ones are we going to trust and which ones are we not going to trust. As a cultural thing, all of us need to just be smarter at making those sorts of decisions, and we need to be smarter at, if we're not getting trust from any of those people, we need to get far smarter at insisting on it. And so the book's got sort of simple things on, how simple criteria, not rocket science, but here's some criteria you might run through if you're trying to work out how to trust an information source. What are its motivations? What's it funded by? Just a few little simple things, but just tick lists that can just go kind of, if we could all be doing this, we'd raise the bar on it. And what to do if you're not getting it, especially come election time. Okay, so the Financial Times criticised this little bit of the book for saying, well, it didn't seem relevant enough. I did a bit about prisons and I did it just because the statistics are so absolutely mind-popping. So if you're a male born in Louisiana, you can expect to spend nearly 2 years of your life in prison. So that's the mean. It's good to be female. If you don't want to go to prison, it's very good to be female. And it's much better to be in the the UK, but even better to be in Norway. And there's a discussion in the book about this, but it's really just coming into the values question. It's amazing, I'm just about to get into the values bit, but it's amazing how many people I've talked to in the course of writing the book, experts in all kinds of technical fields, food, energy, whatever, who've said to me, well, you know what, when it comes to it, at the end of the day, if we want to deal with this stuff, it boils down to our values. It boils down to our values. If we can sort out some values, then we're going to be okay, and if we can't, then we're going to be in trouble. So I'll just have a look at what I think are some conclusions about values that will help humans to survive in the Anthropocene and do well, and values that won't. And I'm not coming at this from which ones are nice and which ones aren't nice. I'm no better place to have that to talk about that than anybody else here. But I'm just coming at it from a purely practical perspective, right? What values, if we could have them, will help us to thrive, and which ones won't let us thrive? So 3 values that I think we can no longer live without. They're not nice to haves, they're must-haves. So really, really simply, here we go. So the first is we're going to need to start treating all people as if they're of inherent equal value, whoever they are, however rich they are, whatever part of the world they come from, which kind of sounds too obvious to mention maybe to some people, but if we even began to live like that, it would have enormous implications. And the good news, by the way, is that there's plenty of evidence from all sorts of things, neuroscience, history, behaviors, that these values, that we're capable of changing them. Deliberate human effort is capable of instilling some cultural norms. We're going to need to respect other species as well, not just as servants of humanity, but for their own right. And third one is we're going to need respect for truth, for its own sake, however convenient or inconvenient it is. We're going to need just to hang on to the concept of if it's true, then it's important. That's what we should be looking at. So I've sort of done the 2 outer rings of the stuff in the book, and then the conclusion chapter is just about some ways of thinking, which I think now we're in the Anthropocene, we need to get much smarter at, some thinking skills and habits. And quick slide on them. So here they are, and they're justified in the book, but we need to get much better at big picture thinking, because here we are now in a whole world, and we need to think in that scale. And we need to get much better at our global empathy, because everything we do affects people on the other side of the world. We need to get better at thinking further into the future. We probably need to get better, and I'm not, by the way, claiming to be master of all these skill sets, but I'm just saying that ones we all need to get better at. Better at appreciating of sort of small things in the present and local, so we don't have to get on a big aeroplane or drive a big fat car or whatever in order to get our kicks. In terms of truth, self-reflection and critical thinking, complexity and complicatedness we're getting better at all the time anyway. We don't need to concentrate on that so much, we're just doing it, but more and more of it all the time. And we need to get better at joining things up so that, in universities, for example, every academic discipline needs to join up with every other academic discipline, because otherwise you can't be sensible. You can't be sensible about what to do next. So I'm getting very close to the end. But just a really valid question to ask when it's also global and systemic. And I've talked about how, small piecemeal actions don't have any effect on the global scale around climate change, for example. When it's also global, what can I do? What can an individual do? Because we're all just specks, aren't we? We're all just one out of 7.5 billion. So I think we're looking for big system change. It's clear we've got to have big system change. And how would we get that? So we need to think about, well, how can I help to create the conditions under which that system change could be possible? And sometimes if you try and change the system, you can push and push and push, and it looks like you're getting nowhere, but actually if you're helping to create the conditions, then maybe when those conditions come right, maybe there's a very sudden flip into a whole new system. So these are the things. First of all, we need to spend more time imagining the future that we want. We spend a lot of time getting scared about what life is going to be like if we can't burn so much fossil fuel. But actually, this isn't about making life worse. This is about making life better. So let's spend some time imagining what a great world might look like. So this is just my quick little sketch. Maybe it could look like that. We could all draw this differently, but I'm just trying to make the point. We're actually trying to create. There's plenty of opportunity for having life better, not worse than it is now. So next up. Be a role model for sustainable living as best we can while still enjoying life, in fact enjoying life more and not beating ourselves up for our shortcomings. But there is something about, even though we're all just only one little speck of it, and I don't find this any easier than anybody else here, I'm sure, but there is something about the personal thing brings integrity to the micro brings integrity to the macro. So it definitely is important, but it's definitely not everything if we're thinking about how can I help create the conditions for systemic change. There's much more about this in the book, but be discerning about how we spend money. So every time we spend or invest money, including the supply chain that you buy my book from, I even talk about, if you were to buy my book, is an investment in one supply chain or another. But especially how our pension schemes are invested, but any time you're in the supermarket, what is lying behind this? What am I promoting if I spend money in this way? Develop the essential values, and it turns out there are things, and I talk about it in the book, that we can do to consciously develop those values. And the thinking skills. Insist on our politicians having those thinking skills, and I think we really can get smarter at that. And in particular around coherence. So, we've had a world in which a politician can talk about climate change over here as though it's this thing that's really important, but when they're having the question about whether to open up a new coal mine in Cumbria or a new airport or whatever, then that climate change has been forgotten about. And we can really push for that coherence and try and live that coherence as well, which of course is more challenging again. And then lastly, I just put this, insist on change. We've had decades of asking for change, and now we're at this incredibly interesting moment where people really are starting to insist on change. And I just put protest with a question mark. I think Extinction Rebellion, I wasn't sure where I'd come down on for what I think about that, and the kids as well, going out on strike. And actually, if not this way, how? And if not now, when? There is real momentum happening now. And I can't tell whether, if we keep pushing, we're going to get there. Is this the start of it all, or is it just something that's going to be fizzled out? I can't tell, but I can tell that the harder we push, the better the chances are. So, cause for hope. I think it's a really interesting moment. I think a few months ago, the traction that's going on around the Green New Deal in the States and possibly in the UK, the Extinction Rebellion stuff, and just by the way, those three values I talked about, they are really hot on those three values of respect for everyone. They were repeating that the whole time in the protests. Respect for all species, of course, and respect, really pushing for truth. So you're right behind them in their principles they're going for. The climate emergencies that are being announced all over the UK, and of course the kids just insisting on a better world and kind of looking after my generation, looking out for my generation. I used to be overseen by a generation that could remember the war, and they've more or less gone now. But luckily we've got a generation that can imagine the future better than we can, and that's kind of, we should be listening to that. So there we go. So in a way, the science is more scary than it's ever been, but also in a way, I kind of feel like the hope is more than it's ever been too. So there we go. That's the quick version of the book. Thank you for listening. Thank you for listening.
Okay, thanks very much, Mike, for a really fantastic presentation, very diverse, very packed full of information. I now know why I don't explode every evening. I know a lot of more relevant things as well that I didn't know before. We have about 20 minutes or so for questions. I suggest we sort of combine them in sort of groups of three. A question is a short statement with a question mark at the end, not a long sermon.
Okay.
I have to choose. I start over there with Alina. Yeah.
In my first job here, I worked with...
Actually, sorry, why don't you wait? There's a microphone.
Oh, great, microphone.
Assume a microphone that's working.
So we can take the microphone upstairs as well if you want to.
I will want to go upstairs. Do we only have one mic? Or? Okay, good.
Okay, we'll just shout and I'll repeat it if it's quiet.
Do a couple down here and then we come up to you in the next round.
In my first job here, I worked with academics who were working on HIV and AIDS, and they found it very frustrating when people framed the problem as a crisis or an emergency. So they found that a negative thing in trying to make progress, and a pop star was like, it's an emergency or it's a crisis. They found that a difficulty in making progress, and I wondered a bit more about your thoughts on, does
Yeah, okay. Actually, do you mind if I take them one at a time?
Do you want to do it?
Because
Okay,
I'll forget them. Yeah.
I know the feeling.
I think it's really interesting. So I think we should. Sorry?
You said you repeat the question.
Repeat the question. Yeah. Okay. Is it useful to talk about climate emergency rather than climate change? And so I think that we should say it like it is. I think it's really important to say it like it is. I think that it doesn't, I hear people saying about how you can't say this because it'll turn people off, they'll be scared off, or, actually, if you want to be accurate about it, it's a climate emergency. So I think it's a useful term to use because it describes what's happening. Does it scare people or not? Well, we need to help, having said it like it is, we need to quickly provide some information about what people can really meaningfully do that makes them part of the solution. And that's how people can deal with it without switching off. So I think it probably is. I need to get used to the language myself, but yeah.
Okay, let's stay in that corner before we go. Just go a couple of rows back to the right, lady with the glasses.
Lady with the glasses? Yes, you, yeah.
Interesting question. I work in finance, so you can come across a lot of these people.
Yeah.
What do you do about climate change deniers?
Just don't. They've had their airtime. Just move on. I think the science is so clear cut. There are all sorts of reasons for denial. A lot of it's about vested interest, and that just needs to have no airtime. And some of it is about some sort of psychological thing, but some of it's about attention seeking. Well, just don't give it the attention. Just move on. We haven't got time for it. We need to move on from that. Yeah.
Very good. Tempted to go upstairs. Just the lady next to Zoe.
Hi, thank you very much. I was wondering, you talk about a set of values like respect that need to be implemented, and around the world, in between countries and within one country sometimes you have different values.
Yeah.
So how do you implement those values worldwide to protect?
Yeah, is it okay to have a big police force saying you must have these values, must have these values? No, but I think it is okay to say that, cultural diversity is fine up to the point of it's not okay to have a culture that doesn't respect all people, for example. So I think that's right. I think we can insist on that and we can call it out. And I think I think there are things we can do that promote those values, including, and Kate Raworth in her book Donut Economics is interesting about this, some of the ways in which we frame up economics encourage us to think in different ways. So we've had arguably some decades where the way economics has gone has encouraged us to focus on individualism and greed and stuff like that. Well, the encouraging thing about that is that it shows it's a variable, right? If we can move in the wrong direction, that's good news because it shows we could do the reverse and go in the right direction. Change the metrics in a different way, and that would help us. Yeah.
Okay, let's stay in that corner. I will get a question from a gentleman eventually, but yeah.
Yeah, okay, so I'll repeat the question. So if business as usual isn't fit for purpose and so much needs reinventing, how does something like the LSE deal with that when so much of how it's traditionally done things may not be fit for purpose, and in particular traveling the globe, all right? So just to cover off the flying thing, first of all. So flying, mostly, overall, the low-carbon world is an opportunity. It's an opportunity to improve, and the sustainable world is an opportunity to improve quality of life. I'm confident if we're smart about how we do it. In a few places, we have to just bite the bullet, though, right? We do not know how to put aeroplanes in the air for long-distance journeys without having a colossal climate impact. That is just fact. So it's not that we can never fly, right? But we have to bite the bullet that we're going to need to be frugal about it. And in my little picture of everything good, the good world, I should have said, in the corner I did actually put an aeroplane, a little one, We can have some flying, right? But in terms of how we reinvent ourselves, I mean, it's about being brave and it's about being imaginative. But loads of companies are in this position as well, you know, and we need to help them find escape routes, because there are, you know, IKEA is finding it's been really inventive about what it's going to do about the fact that in the sustainable world, we won't be buying as much furniture anymore. We'll be buying second-hand and we'll be mending stuff and all the rest of it, and they're finding a way through that. And there are other companies whose response is to try and deny the science and all the rest of it.
Okay, let's move somewhere into the middle of the audience. I'm not quite sure what the value of the microphone is, but why don't we
I don't
try
think that microphone is working, so just say the question and I'll shout.
Gentleman in the front row.
So I was watching this YouTube video and this guy was making a pro-nuclear, anti-solar case. Yeah. And he was saying that if you were to do all the mining you have to do to solve the world's electricity supply with solar panels,
Yeah.
that the damage you do to the environment through the mining would be so enormous that you'd destroy the planet.
Yeah. No, I think he's wrong. So I think he's wrong.
Do you want to repeat that?
So the question is, you know, maybe the manufacture of the solar panels will be such an environmental burden that it knocks a hole in the whole idea of the solar revolution. Turns out he's wrong on that. The amounts of metal work, and there are no particularly rare metals required, all the rest of it that are in short supply. It turns out, the analysis, that, as far as I understand it, is that's going to be okay. So, yeah, that's just wrong. In terms of the nuclear question, it's funny, the nuclear thing, it's impossible to say, I'm going to say it anyway, it's impossible to say anything on the nuclear debate without getting somebody's backup, because I think it's just, you know, even if you just call for open-mindedness, but that is what I'm going to call for. You know, I think it's really complex. The risks and benefits are not simple to understand. And if there's ever a case for nuclear, it's probably stronger in this country than it is in most, because our solar is so rubbish and we need such an interesting higgledy-piggledy energy mix. And what it needs is a really trusted, expert, impartial analysis. And I would just say that we're miles away from having that at the moment. So that's why we need to build up the truth and trust stuff.
Okay, we've acquired another microphone. Let's sort of stay maybe in the middle there, close to Zoe and the microphone, then we move our way over there, but we start in the middle too.
Yeah.
We have another mic, let's see what that one does.
In a school, it can be really difficult to be environmentally friendly, because you've got to use all the paper and all the whiteboards and interactive stuff. It can all be quite difficult. But do you think there is anything specifically that teachers can do? Because I've been asked to tell teachers what they can do to encourage students and change their ways, but is there anything that teachers can do to either encourage students or themselves to become more eco-friendly in a school environment?
Yeah, okay, so I think what a school can do is very similar to what a person can do. So it's partly about managing your own environmental impact, and it's partly about pushing in every way you can. So, you know, it's okay to use a bit of paper and, you know, to buy a computer every now and again, but keep that computer going as long as you can and buy from a brand that's going to make it last and get it repaired and all, you know, all those things. So, you know, and the school can practice all of that. But the big thing that the schools can do, you know, I've talked about values and thinking skills and so on. Well, schools can really push that stuff really hard.
There's a question right there in the middle. There's two hands there. The gentleman with the glasses has been very persistent. Microphone is on its way. A working microphone is on its way.
A working microphone.
Right.
Yeah, I'm just retired from the Chinese cement industry, and on its own, the Chinese cement industry is responsible for about 3% of CO2 emissions. So I was just interested by your comment that we know how to solve the technical problems, in particular for process industries. So I think industry as a whole is about 25% of emissions, and a good chunk of that is process industries like cement and chemicals, iron and steel, where it's not just a question of energy efficiency or the source of energy, we have to address the processes. Do you think we have solutions in those areas?
Yeah, I can talk.
Move the microphone just one up while you're answering. Okay.
Yeah, okay, so I can talk a bit more about would it work for you if I talked about steel instead of cement, just because I've looked at it more recently? Okay, so Cumbria, there's this plan to open up a coal mine in the west coast of Cumbria. It's absolutely bonkers. So it's going to dig up coal with a carbon footprint of something like 400 million tons. It's going to make a joke of anything that anyone in Cumbria ever does for the low carbon world. And the justification, it slipped through the radar for two reasons. One is that it's okay, most of the coal is going to get exported, so someone else is going to burn it instead, and supposedly that's the solution. Seriously, it lets the UK off the hook legally. But the other thing about it is that it's coking coal, and we need it for steel, that's the argument. Well, so we picked into that and had a look. So that's based on the assumption that coking coal requirement has to go up with steel requirement, and steel requirement is going to go up. And that turns out to be flawed in loads of different ways. So first of all, does steel requirement need to go up? Well, in the sustainable world that we're heading for, we're going to be dematerializing. IKEA gets this. We're going to be buying less furniture less of the time, right? We're going to be recycling stuff. We're going to be buying less of it. So the amount of steel doesn't need to go up as projected. In fact, it almost certainly needs not to. Recycling rates are currently about 25% on steel, and recycled steel only requires about a fifth of the energy as virgin steel. So we can radically change that. And as it turns out, technologies for making steel without needing coking coal at all are at the point of piloting at scale, and they're maybe 30% more expensive. So as it turns out, in that particular instance, we have the technology there or thereabouts to deal with that. And cement, we can make buildings in different ways, at least to some extent. So I think we have it there as well. Yeah.
So Mike, thanks for your super talk. I wanted to ask about your advice on how we should vote, who we should vote for.
Oh, yeah. Thank you for asking me. Thank you for asking.
You suggested, for example, there are 14 facts which politicians need to demonstrate that they actually know and understand and are prepared to act on, rather than having them. And you suggested there were various values that we should be assessing politicians on.
Yeah.
So we poor voters, how can we know who to trust on this? Do you have some website in which you rank political parties or politicians in terms of their knowledge and their values?
I don't have that stuff, but I would certainly welcome initiatives to go and put candidates through a test. Absolutely. So, there are some simple, and they're in the book, I can't even remember them all off that, but I did put some simple checklists in, like things like, has this politician ever deliberately, not just lied, but have they deliberately misled, right? Ever, right? If they have, then, have they climbed back from it, had a moment of absolute apology for it and come clean about it, all this, or have they buried? So that would be one of them. So, there's just asking those questions really carefully. I think it's not just how we vote, but it's also how we make sure well in advance of elections that all the potential candidates know our criteria and know that we really take them seriously. And then the other thing that I would say is this thing about coherence, right? So we've had decades where it's just been acceptable. You've been able to get away with it in your political career, to bang on about climate change when you're talking to people who care about climate change. But when you're talking about the airport expansion, you've forgotten your climate change bit. And the same when it comes to the 500 jobs for this coal mine in Cumbria and all the rest of it. And we need to get really sharper on this coherence, right? So that it's like, if a politician's got two totally incoherent policies, then it needs to be, is it that you didn't get that these things didn't match with each other, or is it that you hoped we wouldn't spot it? Because either way, that's a showstopper, right? That makes you unfit for office. So it becomes embarrassing, and we just need to get sharper at that. And then the other thing is, we need a world in which when misinformation does get spread out, we need a world in which everybody calls it out. So recently, for example, Claire Perry, I picked her up on saying that 30% of the UK's energy supply was from renewables now. It turns out it's not 30% of our energy, it's 30% of our electricity, right? It's incredibly different. It's actually more like 5% of the renewables we need to sort our energy supply out. Electricity is the easy bit of our energy supply. When you start replacing heat and stuff, it gets a lot trickier. And, so in the world I'm talking about, everyone would call her out, even all Tory party, everybody from all parties would be obliged to call her out, and she would be obliged to put it straight, and make sure it wasn't just put straight, but everyone that, as far as possible, everyone she'd misinformed understood what the real picture was and the significance of the difference between the two positions. So I just feel like we ought to be able to push for a culture in which that kind of thing happens.
Okay, we're moving to the left. There's a lady right in the corner and then the gentleman just behind her. Where are you going?
There's one thing I just want to say quickly, actually, about the book. So this book was my attempt, right, to do the big picture of everything on the basis that it's better to look at the big picture of everything as best you can, however inadequately. That's actually better than trying to be an expert here, an expert here, an expert. You know, you have to do the best. We have to carry the whole thing in our heads. But it's never been my. I've never been quite arrogant enough to think that I could do the perfect job of this. So I'd like to think the book is a start point, not an end point. So I'm definitely open for, as the thing suggests here, I'm definitely open for ideas, suggestions, improvements, criticisms, and in particular, any ideas about collaborations by which we might work up this kind of big picture, the big picture of everything type thinking. Yes.
Hi Mike, great talk, really, really interesting statistics there. I work in energy and I get into a lot of debates with people who really care about climate change and who really want to make a difference, but the way they want to make a difference is technological. So, you know, they talk about 3 different coral reefs. So what would you say to them that, because I guess fossil fuels is energy's golden child. So
I think it's I think that's kind of the idea that technology will get us through this is really depressing and totally flawed, right? So technology has brought us many great things in life, and in the world in which the world was robust to everything we could throw at it, the more technology the better. Great, we could invent something if it was fun and use it if it gave us efficiency. That's fantastic. We're in a different world now, right? Technology is also part of the dynamic by which we have been increasing our impact on the planet. And this is a really important concept. So efficiency, right? If you don't bag this is something that we really need to get our heads around. If you have an efficiency improvement and you don't bag the savings, then the default is that the impact on the planet resulting from that efficiency improvement will be to go up, not down, right? And that is critical to understand. I've had this with some of I can't name them, but some of the big tech giants, where they've wanted me to do some analysis about how isn't the world lower carbon because of our technologies? And it's been, actually you can't say that because it's not. The world carbon is going up as a result, you know, arguments. And they've been saying, well, so are we working with the wrong consultancy? And I've had to say, well, maybe, because we might be unusual, but we actually really, really don't do bullshit. And we've had to come back to it again and again and again. And I've had, we so much admire your integrity and honesty. Thank you. And then, my goodness, 2 weeks later, you're absolutely back there in exactly the same conversation saying, I thought we agreed you couldn't say that because it wouldn't be true. You can say this because it's true, even though it doesn't sound so nice, but you can't say this because it isn't true. But this idea, it's a wishful idea that technology on its own, it's not that technology isn't fantastic. Technology is part of the solution, but we must bag the savings.
Okay, we have time for 1 or 2 more. So there's a gentleman there who's been patient. Then we move to my left, the left wing.
It's a great book, great page turner. I've Kindled it, it's brilliant. You know, I have no faith in our political civil service structure at all. I'm old enough to remember the Suez crisis, the ERM crisis, the 70s, etc., etc. They don't know what they're doing, Mike. And we've got a transport secretary who's cancelling electrification projects and ordering diesel trains. So I think probably we need to do 3 things, backed up by your work. We need a calculated, thought-through structure. It's a project plan for the future to deal with the 27 million condensing gas boilers and the 37 million vehicles. We don't have that at the moment that I can find, but maybe you're working on that.
No,
Secondly,
you're right, we don't have it, yeah.
I think we must harness the energy of Extinction Rebellion and the school strike and Greta Thunberg, because I think it's going to take us 10 years of civil action continuously to put the pressure on Parliament. The idea that we will elect good politicians who will suddenly see the light, I think is bullshit. I think we need to, thirdly, shape the narrative that you're beginning so that we can show people how doing good is better for them. Because the rhetoric that's around at the moment, people hear it and they're scared about it, it's hair shirts or Armageddon. And we need to find another way of expressing what we're all concerned about that people can easily understand and digest.
Yeah. Okay, so I think I agree with all of that. So Extinction Rebellion, just to talk about them for a bit. I wasn't sure. I really hoped Extinction Rebellion would be great. And I do think they made some mistakes along the way, actually. But overall, I ended up really impressed with them. And the things that really impressed me were, the way that the trust, the truth thing, the respect for everyone, the way they were singing "We Love You" to the police while they've been carried away, the respect for all species. It was surreal. The police didn't know what to make of it. Yeah, that's right. Yeah. So Extinction Rebellion, where was... Wow, damn it, I've lost my...
Think about it. We have another question in
yeah,
the meantime. We'll come back to you. Lady in the front row, right and left.
It was linked to that, actually. Their opinion on the Citizens' Assembly taking politics out of climate change.
Yeah, so we need to get... I mean, democracy's not been working right, has it? I mean, anyone thinks that, I don't want to get too party political about this. The whole thing needs to transcend party politics, by the way, which I hope Extinction Rebellion will keep transcending, but will not get stuck with one party or another or anything. But, sorry, God, my brain must be overloaded. Just repeat the question.
So in politics you have people that from a broad base of the society that I'm assuming, I don't know, that long term going to be sort of supporting and driving the government from as people but not politics. So Citizens' Assembly is using that.
Yeah.
I'm really new to it myself.
No, I think citizens' assemblies are, so improvements to how democracies work. So citizens' assemblies, I think, are a really, really interesting concept. So you get this group of people, not necessarily representative, but as close as you can get to that, and just of everybody, and then you inform them and you have a really structured, transparently impartial process by which you get the experts that they ask for, and they give their input, and then the people give their questions, and there's a process by which anyone can creep out with their question privately, anonymously, or publicly, or whatever, and then the experts have to reply to that, and then they go through this deliberative process. And it's just such a more intelligent way of coming about making a decision than having a referendum or any of that sort of stuff, right?
Okay.
So yeah, interesting.
This is a good way, I suppose it is a good way to stop. Let me just remind you of Mike's job description. Big picture, multidisciplinary thinking about the challenges of the 21st century. I think that's exactly what we have had. So thank you, Mike, very, very much indeed.
Thank you.